What you're seeing here isn't a 3D game, but a group of lines that make it look 3D. But to see how we got here, we'll have to go back in time to when I decided to make my first raycaster. Now, if you watched my previous video, you would know that I make my projects in SFML, which isn't a game engine by itself, and that makes it a little bit harder to see exactly what's going on here, but I still hope that it won't be that big of a problem. Anyways, let's see how I made this raycaster. First things first, I'll make a small map that will be a top-down view of our world. Next, I'll add this map that I made to the top left corner of the window, just so that it gives me more debug information. We'll also need a player, which is in my case just a small circle. I think that now would be a good time to explain how raycasting actually works. The basic idea goes like this. From the player, you fire out many rays, usually for each vertical line of your window, and when they hit a wall, you store their position from which you can later calculate their length. Based on their length, you can make lines on the screen that are bigger if ray length is shorter or smaller if the ray length is longer. This whole process gives an illusion of 3D space, and these types of games are called 2.5D games. Now back on our raycaster project, I wrote this fairly simple code that moves every ray a small amount until it hits a wall. There are many problems with doing it this way, mainly performance, but it is fine for now. The next step is to make lines on the screen with the information that we got with raycasting. Well, it works now, but the result is very blocky, and that is because I'm casting only 10 rays, so I'll change that to 1280, which is the window size on the x-axis. It looks much better now, but there are a few issues. You can see that the whole world has this fisheye effect, which doesn't really look that great, to be honest. Also, FPS is really asking for optimization at this point. I'll start with fixing the first issue. This issue is just a trigonometry problem. We can multiply our ray distance with the cosine of the angle between the specific ray and the rotation of the player. If the field of view of our player is 90 degrees, this specific angle would be in range of -45 to +45 degrees. Also, if you didn't know, in C++ the cosine function takes the angle in radians, which is why I'm multiplying everything with 0.01745533. With this fix, the game looks much better now. The second problem with the optimization is still here though, so something has to be done about this. This issue was much more difficult to fix, and it took me about 3 hours to actually get it right, but it was definitely worth it. That simple code that I showed at the start does work, but it is very expensive when it comes to time. Casting a ray that way took between 6 and 40 microseconds, which isn't expensive by itself, but when you consider that you fire out over 1,000 of them, 6 microseconds becomes 6 milliseconds. Also keep in mind that if we want the game to run at 60 FPS, one frame must take less than 16.6 milliseconds. That algorithm checked many times if a ray hit a block, when we only need to check if a ray hit a block on each edge of a block. This only works for a grid map like this, which we have, so implementing it isn't a problem. This new algorithm has improved performance by a lot, since casting a ray now usually takes less than 2 microseconds. However, it also gives us another ability, which is adding textures to the blocks. Everyone of course knows that pure white blocks look boring, so let's change that. First, I made an example texture in paint.net, and of course that I rendered clouds because I'm too lazy to actually spend more than 30 seconds on a texture. Now you might ask, how am I going to know which part of the texture goes where? Well, it isn't that complicated. Every block in the map has a size of 1. Which means that if we say that the texture has coordinates from 0 to 1, Then when we render, we can get the position of the ray mod 1, and that way we can get what part of the texture we need. And that's it. It works exactly how it should. Just so that we have some variety, I decided to add another texture, which is the same texture but with a changed hue, and added some extra green blocks on the map to indicate these other blocks. And that's it. That's pretty much everything for this video. I hope that you found it useful, and of course you can give me opinions on this style of a video in the comments. And that's it, at least for this one. Thank you for watching.